Hey there, space enthusiasts! Are you ready to explore the latest discoveries in the field of astronomy? In this video, we'll take a look at some of the most exciting recent findings that are changing our understanding of the universe. So, buckle up and let's blast off into the unknown. Number 1, Hubble glimpses globular cluster NGC 6652. First up, let's talk about the Hubble Space Telescope. This amazing instrument has been capturing stunning images of the cosmos for over 30 years. And one of its latest discoveries is the globular cluster NGC 6652. This glittering cluster is packed with countless stars, and Hubble's image shows it in all its sparkling glory. NGC 6652 lies in our own Milky Way galaxy in the constellation Sagittarius, just under 30,000 light-years from Earth and only 6,500 light-years from the galactic center. Globular clusters are stable, tightly gravitationally bound clusters containing anywhere from tens of thousands to millions of stars. The intense gravitational attraction between closely packed stars in globular clusters is what gives these star-studded objects their regular, spherical shape. Number 2, research investigates eclipsing binary CSS J003106.8 plus 313347. Next, let's talk about a peculiar binary star system known as CSS J003106.8 plus 313347. Astronomers have recently performed the first photometric study of this system using a private observatory. Their findings shed new light on this fascinating object. W Ursae Majoris type, or W Uma type binaries are eclipsing binaries with a short orbital period and continuous light variation during a cycle. They are composed of two dwarf stars with similar temperature and luminosity, sharing a common envelope of material and are thus in contact with one another. Located some 4,900 light-years away, binary star system is an EW with an apparent magnitude of 14.73. The observations found that the primary star of this binary star system has an effective temperature of 5,477 K, while the secondary star is 321 K hotter. This finding indicates that the primary and secondary stars have spectral types G8 and G5, respectively. Number 3, city killers and half-giraffes. How many scary asteroids really go past Earth every year? Did you know that there are approximately 500 million asteroids with sizes greater than 4 meters in diameter orbiting the Sun? These chunks of rock left over from the formation of our solar system can pose a threat to our planet. But how many of these city killers actually pass by Earth every year? Let's find out. Asteroids are certainly good at capturing the public imagination. This follows many Hollywood movies imagining the destruction they could cause if a big one hits Earth. Of course, the threats asteroids pose is real. Famously, about 65 million years ago, life on Earth was brought to its knees by what was likely the impact of a big asteroid, killing off most dinosaurs. Even a 4-meter object, half a giraffe, say, traveling at a relative speed of up to 60 kilometers per second is going to pack a punch. Number 4, researchers propose new method for pulsar timing and radio frequency interference mitigation. Radio frequency interference can significantly distort shapes of multi-channel time-frequency radio signals. But researchers have recently proposed a new method for pulsar timing and RFI mitigation that could help us better understand these fascinating objects. The optimized signal decomposition model can mitigate most types of RFI, reducing empirical factors and increase operability. Especially, the robust nonlinearity can overcome the non-Gaussian characteristic of RFI. In addition, detailed signal contents are recovered after residual decomposition to compensate for the loss of measurement sensitivity. The processed data have been applied to pulsar timing. In the experiments, the timing accuracy and time of arrival estimation have been improved to varying degrees. Number 5, team identifies gas streamers feeding triple baby stars. A team of researchers has recently made new observations and simulations of 3 spiral arms of gas-feeding material to 3 protostars forming in a trinary system. These findings have helped clarify the formation of multi-star systems. Most stars with a mass similar to the Sun form in multi-star systems together with other stars. So, an understanding of multi-star system formation is important to an overall theory of star formation. However, the complexity and lack of high-resolution, high-sensitivity data has left astronomers uncertain about the formation scenario. In particular, recent observations of protostars often reported structures called streamers of gas flows toward the protostars, but it has been unclear how these streamers form. Number 6, researchers investigate hard X-ray emission of neutron star low-mass X-ray binaries. Using the observational data of the Hard X-ray Modulation Telescope, the first X-ray astronomical satellite of China, Dr. Ding Guiqiang from the Xinjiang Astronomical Observatory of the Chinese Academy of Sciences, and his team have investigated the hard X-ray emission of neutron star low-mass X-ray binaries. In the past decades, observations of X-ray astronomical satellites have shown that the hard X-ray tail above about 30 keV in Z sources, classified to NSLM-XBS, is uncommonly detected. The researchers systematically analyzed and fitted the high-energy spectra of Scorpius X-1, a Z source, in 30 to 200 keV, observed by HXMT, and found a power law component in the high-energy spectra of 8 observations. Results showed that the power law component of SCO X-1, called the hard X-ray tail, became hard and weak along the evolution track in the hardness intensity diagram. Number 7, XRISM mission ready to explore universe's hottest locales. Japan's XRISM Observatory is expected to launch on August 25. This mission will provide an unprecedented view into some of the hottest places in the universe. XRISM's Resolve instrument will let us peer into the makeup of cosmic X-ray sources to a degree that hasn't been possible before, said Richard Kelly, NASA's XRISM principal investigator at NASA's Goddard Space Flight Center in Greenbelt, Maryland. We anticipate many new insights about the hottest objects in the universe, which include exploding stars, black holes and galaxies powered by them, and clusters of galaxies. Number 8, James Webb Space Telescope captures stunning images of the Ring Nebula. NASA's James Webb Space Telescope has recorded breathtaking new images of the iconic Ring Nebula, also known as Messier 57. The Ring Nebula is a planetary nebula in the northern constellation of Lyra. It is one of the most famous and well-studied objects in the night sky. The new images from JWST reveal intricate details of the nebula's structure, including its complex inner ring and outer halo. Number 9, does the Milky Way's supermassive black hole have a companion? At the heart of our galaxy, there is a monster black hole. Known as Sagittarius A, it has a mass of 4.2 million suns, and it's only about 27,000 light-years from Earth. Sagittarius A is the closest supermassive black hole, and it has been studied extensively by astronomers. But recent research suggests that it may not be alone. Some scientists believe that Sagittarius A may have a companion black hole orbiting around it. Number 10, astronomers discover 5 green P galaxies with double-peaked emission lines. Astronomers have recently discovered 5 green P galaxies with double-peaked emission lines. Green P galaxies are a type of compact starburst galaxy that were first discovered by citizen scientists using the Galaxy Zoo project. These galaxies are characterized by their small size, intense star formation, and bright green color. The discovery of these 5 new green P galaxies with double-peaked emission lines provides new insights into the processes that drive star formation in these fascinating objects. That's all for now, folks. We hope you enjoyed this journey through some of the latest discoveries in astronomy. If you want to learn more about the mysteries of the universe, be sure to check out our previous video on the mysteries of the black holes. And don't forget to like, share and subscribe our channel for more amazing space content. See you next time.